Uh, I want to know if you have any experience with those gold electroforming ceramic crowns.
No, my school never did it.
Because I did for a while. And you know, gold is pretty nice, and with electroforming you have a very good adjustment with almost no gap between the copying and the preparation. And in fact, I had some bad experience with failure breaking during the cementation.
Mm.
Because you have the gold forming is pretty soft gold, and you don't have too much space for the cement. And if you push too hard and don't have time for the cement to flow, maybe because of this I had fracture of the palaton and vestibular independently. And what I saw is pretty much similar with the fracture that you had with this Procera crown over a
Zirconia button.
zirconium bottom. And my experience with the Procera is that at least in Brazil, the technician don't want to miss the copying from Procera. Then they prepared a good adjustment in the border, in the cervical area, and leave a gap in occlusal preparation. So normally we have a problem. The crown don't fits well in the margin, but don't fit well in the total preparation. And you have a gap. If you try to prove the occlusal without cementation, you have a great probability to failure. I don't know if it is your experience is the same.
I mean, it fades from hoop stresses. I mean, obviously you're pressing so much, you don't have enough space on the axial walls for the cement to flow away, or the adjustment is too tight. So you're pressing and you basically are creating hoop stresses, and it's only alumina, right? So it breaks. You need to create even space distribution, and the minimum of space that we need for all ceramic restorations is 50 micrometers. So, I mean, if your dental technician is adapting this too closely, then you won't be able to really adjust the crown. You either cannot cement it to the end, so you cannot push it down to the end, so you'll have a lot on the occlusal side and your crown will be too high. You'll have to grind off the occlusal surface because you didn't press it to the bottom. Or it's so tight that, and especially if it's thin, I'm sure it was thin as well. The margin was thin.
Yes, thin.
So I'm just asking her to give me some finite element modeling that thin margins should be avoided with all ceramic restorations.
But this depends on, including in the preparation. The dentist must
You need space.
give space.
Yeah, you cannot be very conservative with all ceramic restorations.
Suzanne, are dental technicians sending you any all ceramic restoration that failed inside the furnace?
Yes?
They sent me one that fell in half
Yes.
in the furnace.
Yes. They all have problems with thermal cracks, and they have it in the zirconia framework, and it happened. You would give me another hour, I would be able to show you pictures. But thermal cracks of the zirconia framework are not so rare. What they do wrong, I don't know, but I can tell you if the crack is pre-sintered or post-sintering. If you see a crack by transillumination, You cut off that little piece that is cracked, and the crack opens by itself as soon as you cut it off from the piece. And then you go under the scanning electron microscope and you look at the grains. If the grains are fused together, it's post-sintering crack. That means something in the oven went too fast, either it cooled off too fast. If it's pre-sintering, that means it's in the green stage grinding. You know, the burr is banging in or something is happening. By the way, they never do quality control in the green stage, and they rarely to never do quality control post-sintering via transillumination. Only if they're upper level, they don't want the problem to repeat too often, and then they will come and ask you, what's the problem? The problem is you give them an answer and say it happened after sintering, and you ask them, how did you put it in the oven? Did you put it on a cotton, on a metal stub? And then you don't receive any information. So it's a long story to get the whole story straightened out. But yes, they come and ask me to at least analyze the piece. Yes.
Question?
Just to add to that, I've seen thermal shock in inlays and onlays that were laying down on a wool-like fiber
Yes.
that was protecting it. And then for the thermal shock of zirconia, we got one from Erlangen, from Matthias Karl, that was a zircozone framework. So it's centimeters thick.
Yeah. I had the case from
And
George.
from George. Yeah, George was with it. And it was a cantilever. It was only a molar that didn't last 2 weeks. Huge chunk of zirconia, and it was thermally cracked. Very large thermal crack.
But it was also grinding.
And there was grinding damage as well. Yeah. up
Grinding,
top.
huge grinding damage on the
And
outer
then I think
surface.
on your chip on the intaglio surface against the zirconia, I think that's just proof of binding.
Which chip?
The chip on the inside, and then your hoop stress
Yeah,
failure
could
was
be.
90 degrees to that. So that chip that came out is probably just absolute proof of binding that set up the hoop stresses for your first crack.
Could be, yeah.
Questions? Susanne, just because you made me feel so bad after showing my picture in 2003, and now I see you can all see what happened to me after 8 years and 3 kids. I would like to ask you a difficult question.
In many pounds.
If you would now, as a fractographer, as a dentist, as a prosthodontist, if you would make a checklist to avoid chipping of porcelain over zirconia, from the clinical point of view and at the technician lab, how would this checklist be? What should be?
Okay. First of all, I will only work with a laboratory that is not counting the hours of work. You know, very good upper level laboratory. Second, I'll make sure that he knows all the knowledge that we're talking about, how to treat the material, how to work with the material, how to put the veneering, combining the veneering ceramic with a zirconia. How often do they use wrong coefficient of thermal expansion materials because they prefer that veneering ceramic versus that one, and they're not all compatible. I'll make sure that he knows that he needs to do slow cooling. And the evidence is even now that it's not just the last firing cycle, but probably on all firing cycles. Because the manufacturers are still only saying last firing cycles. The evidence is now every firing cycle. So first, it's an interaction between me and the laboratory. We discuss design. If his abutment is not high enough, he needs to individualize it. I'm talking about implantology. There is nothing that he does before I do not discuss things with him. The second thing is then me, the dentist, the student, whoever. I tell them ceramic is very brittle. Regardless what you have in the hand, this is not metal. You have to be very gentle and go slowly. My first worry are the contact points. mesial and distal, because you get the crown from the lab, you can be sure you cannot put it down because the contact points are too strong. So if you, at that point, you already press it down, or then you already break it. So I take a lot of time adjusting mesial and distal contact points before I even check the occlusal surface. Then comes the occlusal surface. And here again, piano, 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 pianissimo, pianissimo with the patient. I really teach him. I first try to tell him without the crown, and if he's doing fine, I say, okay, now we can go. And I go, and then I definitely adjust the occlusal. I take every contact point that is on a cresta, mesialis or distalis on the occlusal surface. I take it off. I only keep contact points in the middle, or at least where I know that I have a core material. Because there's nothing worse than a chip after one day that gets you off the contact point. Contact point, that's it, you're done. A chip on the palatal side, you can polish it off. Contact point is terrible. So I just tell people it takes time, don't rush. And then, of course, the final cementation, you should not screw up the final cementation. I mean, I am not anymore, I used to tell, bond it with a resin-based cement. Believe me, I had to take off a bridge made in Singapore, 3-unit bridge, 1 centimeter, zirconia, 2.5 hours. 2.5 hours. I had to grind off the last square millimeter. I tried to bang it off, nothing. And that's when I realized this damn cement, resin-based cement, is really good. I don't know what they did. I don't know if they sandblasted or not. I can tell you, if the fit is fine, it's not rotating like this. If it's a good CAD/CAM machine, it's a good fit. I go with glass ionomer. Unless I have a height problem. The classic prosthodontic questions, little molar 2 millimeters in the back, then I will bond it again. Because the reintervention is, I don't know how many problems we'll have in a few years from now on, but I can tell the reintervention is much worse than with PFM, glass ionomer. We just cut through, you bang it off, and that's it. 20 minutes, you're done. Now, with zirconia, you have to grind off everything. Everything. That's everything that is bonded, but what I mean, you can break it off easier, the lithium disilicate. Zirconia is more complicated. Okay. Now, the accelerated aging, I must admit, there are warning signs. Watch out, watch out. We don't know what's going on with time. We are currently with Chevalier. We're doing focused ion beam slices through accelerated aged zirconia ceramic. And we can prove that it goes down 8, 10 micrometers. With accelerated aging, equivalent 20 years, whatever that is. Now, I will be very honest with you, Thomas. 8 to 10 or 20 micrometers. If the thing is 1.5 millimeter thick, I don't care. So, if it's highly polished, if the surface remains highly polished, and that's the only thing we have to do is to verify the occlusal surface after 1 year. You go back and repolish that occlusal surface. I think we may be fine. Do we like the aesthetics? I don't like it. I personally would not like to have full contour zirconia in the front. Never, ever. In the back, I'm not sure. So my experience